Greetings and welcome to another connectivity training module. In this module we're going to be talking about the protocol Codenet. A brief history of what is Codenet. Way back in the dark ages we had a printer called Codebox. Codebox had a protocol called various names, but commonly called by the time the last one was made issue 7. Although its real name was its part number. They used part numbers as this was the code that was blown onto the EEPROM. In those days, networking products were in the infancy and we mostly did RS-485 or RS-232. When a controller was written in Cambridge, they took the code from Codebox and the net from network, joined them together and called it the Codenet controller, the Codebox network controller. Issue 7 then often got called Codenet, which stuck as the name for the protocol rather than the controller. Codenet is still in printers today and is the only protocol in our inkjet printers that is available on both RS-232 and Ethernet TCP/IP. Codet's very popular as it allows a drop-in replacement of an A-series inkjet to replace its predecessor. About the module. In this module we demystify Codenet and show how easy it is to use. We will see how its packets are constructed. We will see different types of packets. It is assumed that you know about comms. If not, there are some modules that we have on comms that will help you with that. We also assume you can connect a printer to a controller and that you're fluent in the hexadecimal numbering system. Codenet is available on all Domino A-series inkjet printers. Codenet is available in 3 backwards compatible versions. Codenet 0, all printers prior to the A-series, so that's all printers that were built before 1998. Codenet 1, all printers from A-series, including A-series Plus and A-series iTech. And Codenet 2, all printers from A-series AX. Codenet is available via RS-232 or Ethernet TCP/IP. Let's look at the packet construction. As with any protocol, we need to know how the packet is constructed. Codenet is fairly easy to understand. It starts with an escape, followed by a command, followed by some parameters, and followed by the end of text. The size of bytes in each of these. The escape is always 1 byte. The command can be 1 or 2 bytes, and the parameters can be from 0 to NN. The escape, the end of text, or at the end, the 04 is 1 byte. So let's look at the Codenet packet structure. All packets start with an escape, which in hex is 1B. All packets end at the very first instance of 04, the end of text. So you can only ever have the 04 once in the packet, and that demarks the end of the packet. Packets may contain more than one escape, 1B. After each instance, there will be a command of 1 or 2 bytes. Any bytes received between the 04, which is the end of the packet, and the start of the next packet, which is the escape 1B, are thrown away. So any misformed packets will get thrown away. All commands that end with 04 will solicit a reply either of data, an ACK, which is an 06 in hex, or a NAC, which is 15 in hex. After a NAC, there is 3 bytes that help detail the actual error. Packets are synchronous, which means send one and wait for an answer before sending another. Codenet commands. All commands are 1 or 2 bytes. 2-byte commands all start with 4F. These are additional commands and they've been compatible since Codenet 1. So if you have a Codenet 0 system and you have a 2-byte command starting with 4F, you know it will not work. Similarly, on Codenet 2 systems, commands that are only used in Codenet 2 start with 7E. Each command is only used once, although you can have a get and a set in that command. Details of the full comms commands and payloads can be found in the protocol document for Codenet 2. Let's look at a Codenet get example. So we want to get the print delay. The command we use is 46. So the get command to send will be 1B46. The parameters here are which head. We only have one head, which is 31. The question mark for a get, because it's a get, it uses a question mark, is 3F, followed by the end of text, which is 04. What we will get in reply will be 1B, which is the escape, the command 46, so this is a reply for this command, and the parameters here will be 1 byte for the head and 5 bytes for the delay value, followed by end of text. A little note at the bottom, and you'll see some of these notes in the protocol document. They are just to provide some more information. The delay values of 0 and 1 are interpreted as 2. So any value in here that is less than 2 will always be interpreted as 2. The Codenet set example. So in this one, we're going to set the print go delay using command 46. So to set it, we have the escape, the command 46, which head are we going to be sending this for, and the delay value, and we will have the end of text. Once the end of text is seen, it will know that that command is complete, and it will send back to us either an ACK, which is 06, a NAC plus the 3 bytes detailing the error. So if any of these items in the parameters are incorrect, it will return a NAC. If everything worked well, it will return an ACK. I hope you see how easy Codenet is and hope you enjoy using it. Please look for our other protocol commands, modules, and enjoy them as well.